Okay, students, welcome back. Let's cover the next section, section 1.2. Let me share my screen. Okay, section 1.2. Okay, basic ideas and terminology. Okay, for differential equations. Basic ideas and terminology. Okay, definition. A differential equation that can be written in the form a naught or a sub 0 x y to the nth power, or sorry, y to the, it's not a power, it's a derivative, y to the nth derivative, okay, plus a1 of x minus 1th derivative. That's why it's in parentheses, because it's a derivative. Okay, plus dot plus, okay, a sub n of x y is equal to some function of x, only dealing with x and not y's, okay, where a sub 0, a1, an, and f are all functions of x only. Is called a linear differential equation of order n. It's called linear differential equation of order n. Okay, so they're kind of descending order of derivatives. Okay, so think of this, maybe this would be y to the second derivative, y to the first derivative, this would just be y, okay, to the 0th derivative, which is just y, and then f of x, which is some function of x. It doesn't have to be x, it could be a constant as well. Okay, and any of these terms don't have to exist either. I mean, if the first term doesn't exist, then you don't have an nth order differential equation. You have, whatever term comes is highest. Okay, let's do another definition. Okay, a function y equals f of x that is at least n times differentiable okay, at least n times differentiable on an interval I is called a solution to the differential equation 1i. If y equals f of x, y prime is equal to f prime of x, all the way to the nth derivative, y to the nth derivative is equal to the nth derivative of x, substitutes all of these substitutes into the differential equation and reduces it to an identity. Okay, number one, verify that y of x equals c1 e to the 2x plus c2 e to the negative 2x is a solution to the linear differential equation y double prime minus 4y is equal to 0. I want to prove that that thing is a solution. So how can I prove that that thing is a solution? Well, we could take the first and second derivatives and see that we get something that is equal to 0 by plugging it in. Okay, well, actually, we don't need the first. We only need the first derivative to get to the second derivative because we don't have a first derivative in our equation here. We just have y double prime minus 4y is equal to 0. So let's look at our solution, our potential solution. Y of x is equal to c1 e to the 2x plus c2 e to the negative 2x. Okay, and then I want to take my first derivative. This is going to be c1 2 e to the 2x. Okay, this is going to be minus c2, let's do c plus c2 times negative 2 e to the negative 2x. Okay. So now let's take the second derivative. And this is going to be bring down the 2, again, chain rule, right? This is going to be 2c1. Okay, 2c1 times 2 e to the 2x, because the derivative of the 2x is just e to the 2x. We pulled that other 2 in front. Okay, plus c2 times negative 2 times negative 2 e to the negative 2x. Okay. So what does this become? Y double prime becomes 4c1 e to the 2x plus the two negatives cancel out, the negative 2 and the negative 2, plus c2 e to the negative 2x. So is that a solution? Okay, we've got y double prime of x here. Okay, is this thing. That's y double prime. So let's plug this in. Let's plug in y double prime and let's just plug in y. Okay, into our differential equation. This is the differential equation that we want to plug into. So let's plug that in. Okay, we're going to get y double prime minus 4y, does that equal 0? So what is y double prime? That's 4c1 e to the 2x plus, oh, I messed up here, plus 4, 4c2 e to the 2x, negative 2x, e to the negative 2x. Okay. So that's y double prime. That's all of this guy. Okay. And then minus 4 times my original, which is c1 e to the 2x plus c2 e to the negative 2x. Does that equal 0? Well, I distribute the 4. Okay. I get 4c1 e to the 2x plus 4c2 e to the negative 2x minus 4c1 e to the 2x minus 4c2 e to the negative 2x. And yes, everything cancels out. And we end up with 0 is equal to 0. So yes, it was a solution to the differential equation. Okay. What was the solution? This guy here was a solution. Okay. Okay, should put that in a different color. They'll make my solutions green. Okay, there's my solution. That was a solution to that differential equation. Okay, because when I took the second derivative and plugged in that and the function, the original function, I ended up with something that equates 0 to 0. Okay, let's look at another definition here. Definition, a solution to an nth order differential equation nth order differential equation on an interval I is called the general solution on I, the general solution on I, if it satisfies the following conditions. One, the solution contains constants C1, C2, all the way to Cn. And two, all the solutions to the dE can be obtained from assigning appropriate values to the constants. Okay. So let's see. So we've got these C1, C2, Cn's. Okay, the solution contains these values, and all the solutions, the family of solutions, can be obtained from assigning appropriate values to these constants. Okay, so let's look at an example here. Find the general solution to y double prime is equal to 12x. Very simple linear differential equation. Okay, so we have y double prime is equal to 12x. So if we integrate this y double prime, we would get y prime, the first derivative, okay, is equal to integrate with respect to x. This would be x squared over 2 times 12, which is 6x squared, plus C1, that's a constant 1. Okay. Okay. If we do that again, we integrate both sides, we would get y is equal to, this is going to go x cubed over 3, so 6 over 3 is 2. 2x cubed plus C1 is a constant, but when I integrate the constant, it becomes C1x plus C2. Okay, and so this is a general solution. Now, if I wanted a particular solution or a unique solution or one of the curves of the family, I would pick values for C1 and C2 appropriately. Okay, so that's our next definition. A solution to a dE is called a particular solution or unique solution if it does not contain any arbitrary constants. Not contain any arbitrary constants. Okay, so next definition. Okay, an nth order differential equation together with an auxiliary with n auxiliary conditions okay, auxiliary conditions of the form y of x naught is equal to y naught, y of x1, I'm sorry, y prime, this should be y prime x naught. Y prime x naught is equal to y1. Okay, all the way to y to the nth derivative x naught is equal to yn minus 1. Okay, where y naught, y1, dot, 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 yn minus 1, okay, are constants is called an initial value problem. Okay, initial value problem. Okay, or IVP for short. Okay, we'll be having a lot of initial value problems. Okay, a DE will always have a particular solution if for the nth derivative is equal to f of y to the nth derivative is equal to f of x, y, y prime, dot, dot, dot. It contains all of the subderivatives, y to the n minus 1th derivative, where all n minus 1 auxiliary conditions are given. Okay, so you're like, what the heck does that mean? Okay, well, it just means that we can find a particular solution if we are given what the derivatives, all the derivatives are equal to. Okay, if we're given what all the derivatives are equal to, then at that value, then we can solve a particular solution at that value, x naught. Okay. Okay, let's look at an example here. Okay. Solve the initial value problem for its particular solution. Okay, we have y double prime is equal to 18 cosine x. Okay, and we have y, the initial condition. Okay, y naught equals 1, and y prime naught is equal to 4. Okay. So if we integrate this, we get y prime is equal to the integral of 18 cosine x dx. And so y prime would be equal to 18 sine x plus, call that c1. Okay. Okay. If we look at our initial condition, y prime of 0 is equal to 4, we can solve for c1 right now. And because if we do y prime of 0 is equal to 18 sine of 0 plus c1, that's got to be equal to 4, right? But sine of 0 is just 0. And so this thing goes to 0, so c1 is equal to 4. Okay, so we get y prime is equal to 18 sine x plus 4. Okay, and then we want to integrate this guy. Okay, and so with respect to dx, and that's going to give us, well, let's go to the next line. Y is equal to the integral of 18 sine x plus 4 dx. Okay, and so we want to integrate that, and that becomes negative 18 cosine x plus 4x plus, I'll call this c2 for y. And then we want to plug in at y naught, we are equal to 1, right? So y naught, we are equal to 1. So this is negative 18 times the cosine of 0 plus 4 times 0 plus c2 is equal to 1. Okay, and so this goes to 0. Cosine 0 goes to 1, and so y naught is equal to negative 18 plus c2 is equal to 1. If I add 18 to both sides, I should get 19. So c2 is equal to 19. And so my final solution, I'm going to bring this down and replace the c2. We get y equals negative 18 cosine x plus 4x plus 19. And that's my particular solution. Okay. Okay, I think that's it for section 1.2, and I will see you in the next section.